State Buckeyes. Hey!
I'm sorry?
Ohio State Buckeyes, that's my friend.
No. We can't support anything Ohio State here. Are you a Buckeye?
Yes, I'm a Buckeye.
Oh, no.
We look forward to the game with Illinois, a junior high school defense.
It's interesting, though, the guy, Art Robinson, I think his name is, from Michigan. It's pretty unbelievable.
Yeah, I expect that will become a good game again.
Yes. It's been quite a few years. Michigan gave Ohio State on the first line.
Yeah, no. I've enjoyed that period, but we'll see. There was a long time Ohio State didn't give Michigan any
That's
trouble
true.
either.
That's true.
It tends to go in cycles.
Are you from Ohio originally?
Yes.
Where in Ohio?
A town called Medina, which is between Cleveland and Akron.
Okay.
At that time, it was a county seat, country county seat town. Now it's kind of a mutual suburb.
I was one phone call away from moving to Canton
Oh, yeah.
about 6 years ago.
To work with who?
A small finance company that's based in Canton, but basically works on financing used car lots.
Oh, yeah.
Seems like a whole different life.
Good afternoon. I would like to welcome all of you to this symposium. My name is Hamid Rastupur. I'm the director of the Wenger Institute for Renewable Energy Research at IIT. We call it WISER. By no means we are wiser than the others, but we call it WISER. And this project and many others is under overall direction of the WISER and put the interdisciplinary teams that we can handle. And we are very pleased to have the faculty which saw the outstanding quality and the connection who can bring this project and handle, such as Muhammad and the rest of other 49 faculty involved in the WISER. Our overall mission of the WISER is, while we are continuing the well-being of human beings, we will try to focus on not consuming a lot of resources and also would not harm the environment. And this is an interesting job to do. In order to achieve that, we wanted to really move from the carbon-based fuel to non-carbon-based fuel in general, and look at the umbrella of decarbonization, and at the same time, we are looking at the umbrella of least cost strategy to reach our goals. This is the overall picture of the WISER. We are involved in a lot of issues. We are involved in 3 major category research: energy efficiency and conservation, energy production, which is the renewable, and wind is part of that, and energy distribution, which is the smart grid and electricity initiatives, and all of those is part of how we can bring the energy to the consumer. So we have a specific area of the focus that we are putting teams together, and there are 4 major areas. These areas is sustainable, smart grid, renewable, including wind, and clean coal technology. These are the focus areas, and we will be fortunate, and with the help of our faculty and the credibility of our faculty and our partners, we will be able to raise more than $35 million during the last 1.5 years. And we'll continue to attract more creative minds, first of all students, because they are the ones who are doing the job, and then the faculty to this university, and reach out to more people in the government sector, in the industry, and bring the teams together. This symposium will really, the intention is bringing the leaders from academia, industry, and government together to work together and focus on the application of and implementation of the wind energy in the future. We have a very distinguished speakers here. sitting in front of you. And I want to put few rules there. I want to put 15 minutes rule because we want to give opportunity to everybody. These things are going to be videotaped, so will be available to the broader audience than the one in this auditorium. And also, this will follow by a panel discussion. Andrew is going to run the panel discussion, and he's also is going to distribute some kind of cards that you can fill out and write your questions on that one. And please turn off your cell phone. I sometimes forget myself. I think you're going to enjoy that. The list of our distinguished speakers include Brian Connor from U.S. Department of Energy, Sonny Garg, President, Exelon Power, and Senior Vice President of Exelon Generation, Michael Polsky, President and CEO of Invergy, Paul McCoy, President of Transelect, Kurt Yeager, former President EPRI and Executive Director of Galvin Electricity Initiatives, Joshua Milberg, First Deputy Commissioner, City of Chicago, Department of Environment. I'm sure you're going to enjoy, and if there is any burning questions, and if the speaker speaks less than 15 minutes, we will be opportunity to entertain one or two questions after presentation. Our first is Brian Connor.
You haven't heard what I said yet. What I'd like to talk to you about is the recent grant award that we just made to the Illinois Institute of Technology. It was an $8 million award, and it's went to several universities around the United States, including Illinois. It was meant to establish consortia that were led by the university and involved industry partners, and I'll explain a little further why. So I'll tell you a bit about why we did this. I'll describe somewhat the competitive competition process because it will tell you a bit more about our method to our madness, and as many of you are involved or will be involved in trying to obtain government grants, provide some insights into that process. The R&D curriculum efforts at the Wind University Consortia were spread beyond just the initial 3 awardees, and I'll talk a bit about who they are and what they're doing. And then I'll talk about our core program, our continuing program called Wind for Schools. The awards that were made under the Wind University Consortia were made under the ARRA, the American Recovery and Reinvestment Act, the stimulus bill. It was 2-year funding. I've only seen legislation like this passed twice in my career in Washington, and it actually provided money for bricks and mortar projects, which allowed for capital investments throughout the United States, and that was the stimulus part of it. In our case, it was used to provide funding to put up wind turbines or engage in research in which you need to purchase and acquire capital equipment to do the research. So with that, what we were trying to get at, and this was a big need for us, is that we have a couple of utility scale research and development turbines at National Renewable Energy Lab in Boulder, Colorado, and we call it an extreme wind event site where they are located. The winds blow very strong beginning around this time of year through the spring. In some cases, you can't even measure the wind velocity because it's so strong, but during the other period of the year, it hardly blows at all. And it's not really reflective of the wind regimes where you usually put commercial applications of wind turbines. So we wanted our research and development to be more relevant to the actual circumstances in which you about this industry. We wanted to particularly engage the university research pool, an underutilized pool that we haven't used extensively within the Department of Energy in the past. So that was one of the reasons why we wanted this to be university-led. And we also wanted to make sure that industry was involved, because we didn't want research that was going to be non-transferable to the private sector. We wanted it to have relevance. We wanted the industry to be involved in defining the research and development agenda. We wanted the industry involved in developing the next generation of talented people at the university level that they needed to come into their industry. And so the emphasis was in providing industry involvement, private sector involvement in defining the curriculum. We put this into 3 criteria, and these criteria were used to evaluate the many applications that we came in. And we had, I can't give you the exact number, but something like 49. And the criteria were then, we would bring in a merit review panel. We try to attract the top level PhD people that we can throughout the United States who have an expertise in the area to come in anonymously, review the applications, and take criteria that we were looking at. We wanted projects that could be deployed quickly in relevant wind regimes. That was sort of the Recovery Act stimulus part of things. We wanted research that had a good project plan, was going to address what we had described as our research path forward to a country that would be consuming 20% of its renewable energy, electricity consumption from renewable energy from wind resources. So we were looking at the research proposals against our long-term programmatic needs. And finally, we looked at their curriculum and if they had, if they were going to provide some subsidies for students who really wanted to get engaged in this area. We also, after we did that, and the merit review panel racked and stacked those proposals in terms of highest to lowest, and of course your university was right at the top end, one of the reasons why you got this grant. We would then look at certain factors at a programmatic level that was desirable. We wouldn't want to have, for example, being made to 3 schools in your state. We'd want to see them spread out. We'd look at the relevance. We'd look at how it was helping us in a policy way. We didn't want to have duplication of research efforts, so we needed some diversity of technology. We looked at the cost share because anyone who could come up with more than just the minimum 10% match, for example, was given a little extra credit for that. When you take that criteria, we needed to map it to our decision-making process, and you'll see how the merit review criteria was scored, how we had a very diverse membership of our peer review, independent review, and how then we took those factors at the program level and applied our criteria and scoring to it to arrive at that final decision. So the 3 top scorers were University of Maine and Minnesota. We used the Recovery Act money for that, but when the panel scored the schools, we also had some alternates. These schools were alternates who were determined to be technically sufficient in all the criteria, and if you had additional money that you could give them to do certain things, they were qualified to do the work. So 2 more universities were given funds to engage in offshore R&D on wind turbine offshore R&D projects, and that's a major initiative that we want to undertake next year, so we were able to provide some seed funding to 2 schools there. And the remaining schools on the list, we gave funding to particularly develop their curriculum and to bring wind technology, renewable energy into curriculum, new courses, and other types of programs. Here you'll see a picture of where your school's turbine is going out. It's 1.5 GE megawatt turbine, which is one of the most popular, probably it occupies maybe 40% of the 30,000 utility scale turbines that are out there. So it's very relevant. We actually have a GE 1.5 megawatt turbine at our DOE facility at Boulder, Colorado, but this one will actually be sited within a wind farm, which is a great opportunity. It's not going to be standalone at a lab site. It's going to be within a wind farm, and that gives us some tremendous research opportunities and helps to underscore the relevance of the research findings. There's work that's being done on small-scale wind turbines. This particular model you may have heard about is the Virid, and we just had a great demonstration of the lab scale model that they have that they're using to conduct research and development. And what's the name of the building where you have that hidden? Siegel Hall. Yeah, fantastic. And so we're going to look at that. That's another great growth area for wind is at the residential area, residential level. But this will help to take the technology to make it more reliable, to reduce the cost of it, and those are two major issues in deploying it on a smaller scale. You'll see some of the curriculum that's under development and in development. We just got a briefing on one of the courses that's already out there and it's being offered at the undergraduate level. And also the approach with the, what was it, the iPro. Sounds very exciting, very real-time, real-world type of educational experience that you would get in the private sector. Here's a look at what they're doing at the University of Minnesota. They're using a larger Clipper Wind Energy 2.5 megawatt wind turbine. They're putting it in a new ground-up community. They're building this community from the ground up, a little bit south of St. Paul, Minneapolis, where the turbine is going to be the linchpin. It's going to actually be the first physical infrastructure that they put into that particular community. They'll be doing some innovative things too with that particular turbine. The tower that you see that man hanging from is made out of steel, in most cases in the United States. This is probably going to be the first situation in which they're going to build that tower using concrete in the United States. They do it in Europe, but this would be the first applications there. They're also going to look at some technology and test that out with their turbine. They will do some similar things in the research area to what's being done here, but we made sure that when we looked at their statement of project objectives that there wasn't any duplication between what's going on in your university and what's going on over there. They'll look at some particular problems that they have up in the far northern climates, for example, with icing and fouling mitigation, which is a little bit different. And we're going to look at radar interaction with wind farms. I could spend another several hours talking to you about the effects that wind farms have on radar and how we're trying to deal with that particular problem because it raises issues in the siting area. So they are doing similar things, but I would say in the curriculum area, each one of these universities, we didn't prescribe what folks had to do with the money that they were going to do with their curriculum. I think we provided the money with no strings attached in that sense. We allowed the universities to design the curriculum to fit within their unique structure and what would work best. What really was heartening to me this morning when I asked a question of the consortia when we were there is I asked them, given what you saw about what the curriculum is that you have today, and if you could just wind back the clock for a little while and say when you were back at school if you had an opportunity to take this course or get involved in this iPro program, would that have helped you better for the job that you have today, or for somebody coming right said, and they were unanimous. I mean, every testimonial that came out said, this is just fantastic. It has so much relevance to what we're doing here, and it was the best testimonials I could hear. The University of Maine is the third major award winner. They are looking at, if you look at the left, well, they're going to do their work out on the Gulf of Maine. What we're trying to do is to leapfrog over where the Europeans are in offshore wind energy. They're building their turbines with conventional turbines that were designed for land-based applications, but we need turbines that are designed for marine applications. So they're going to be looking at platforms. They have some specialized expertise in composites that use plastics. They're more expensive, but they're more long-lasting, and they take less maintenance. So much of what they're doing is laying the groundwork for the deployment of the next generation of wind turbines in the Gulf of Maine. Maine, as you may know or may not know, doesn't produce much energy of its own indigenously, and they are looking at how they can leapfrog their economy to a more renewable energy economy, and they have done some terrific things to promote wind energy within their state, so that they eventually want to create an infrastructure in which they will be a net exporter of renewable energy within the Northeast. Quite an interesting vision that they have for the future. And here again is the type of, the difference between this curriculum and what's going on with the other schools is really geared towards a offshore wind energy specialization for their graduates. So the Wind for Schools is our bread and butter kind of program that we have a number of institutions, in addition to the ones that were listed there before, who are involved in developing curricula, working not only at the university level, but through the K through 12 level. Occasionally, we were able to get some surplus wind turbines that we can actually install at rural school locations so that they can merge the curriculum with the technology at the site, which is a great opportunity to influence the next generation of students coming up through the ranks. So with that, I will conclude. There's my contact information, and should I turn it over to the next speaker? Sure, okay.
Thank you very much.
Thank you.
Our next speaker is Sunny Guy. He's the president of Excellent Power. Sunny?
Thank you. I'm going to keep Brian's information up there just because it's more interesting. I don't have any slides. I thought, first of all, let me thank Mohammed and the others for inviting myself and Exelon to be here today. I always find academic environments so exciting and invigorating, which may explain why it took me a little bit longer than the 4 years that people normally take to get through college. But I thought what I would do today is talk a little bit about Exelon's view on wind as a big generation, transmission, and distribution company. And to do that, I thought cover 4 areas with you. One is, who's Exelon? Who are we, and what do we look like today? 2 is, what's our vision for where we think energy is going? 3 is, where does wind fit into that? What do we need to do together to advance wind and the utilization and the increased implementation of wind as a resource? So first, who's Exelon? From a market perspective, Exelon is the 2nd largest electric and gas utility in the country. Probably more important to us, or equally important, but more important, is we're the least carbon-intensive company, utility in America. So we have about 25,000 megawatts of generation that we do. 70% of it is nuclear, and the rest is a portfolio of other technologies, including hydro, wind, solar, and then some of the fossil fuels that we're all familiar with. And we also, in addition, we own a couple utilities. We own ComEd here in Illinois, and then we own PECO out in Pennsylvania. So we're a pretty big company with lots of different interests in the to distribution side of the business. Let me talk now, secondly, about where do we think energy is going. For us, climate change is very real. We don't think there's any conversation to be had about debating whether climate change is real or not. We believe it's real. There may be other folks who don't, but for us, it is. And we are very actively involved in climate change legislation, and we believe very firmly that whether it's through congressional legislation, whether it's through renewable portfolio standards, whether it's through EPA regulations, we will have a cleaner energy future. And so that's what we are trying to build. And as part of that, what we put out a few years ago is a document called Exelon 2020, which basically is our commitment to eliminate the equivalent of our carbon footprint that existed in 2001 by 2020. So that's about 15 million metric tons. We've eliminated about half of it already. So we believe we can get to the end state and eliminate all of it. But for us, as we think about climate change, cleaner energy future, what's important is the intersection between the environment and business, right? And so what we're looking for when we're looking for opportunities to offset our carbon footprint, as well as think about opportunities to solve that problem more broadly for the country, is really three legs of a stool. Right? One is it's got to be safe and reliable. The electricity's got to be safe, it's got to be reliable. Two, it's got to be cost effective. I mean, at the end of the day, customers have to pay for this. So, the cost piece is an important piece. And then three, obviously, to get to a clean energy future, you got to have a clean type of energy. So for us, when we think about opportunities in the portfolio that's going to solve this problem, it's really thinking about those three legs of the stool and making sure that they intersect in a way that's most that's best for the customer and the environment, right? So recently we just did a deal. We bought John Deere Wind, John Deere Renewables, because it was about 1,000 megawatt at the end of the day, but it was also economical, the way that it was set up. And so that's an important piece for us. And so the third piece that I wanted to talk to you about is not only where we think we're going to go, but where does wind fit into that? And that is really a portfolio view, right? We don't think there's a silver bullet here in terms of solving our country's energy problems and getting to a cleaner energy future, which is why, for us, we're investing in things like energy efficiency, right? We've got a huge project out in Pennsylvania on smart grid. So we're investing about $600 million in smart grid. We're also looking at uprates on our nuclear plants to get more megawatts out of the existing. But renewables is an important part of that. And again, that's why we were buying this John Deere facility, because we think the renewables is an important part of the solution of how we're going to get to a clean energy future. So wind is not in and of itself alone the silver bullet, but we think it's part of a portfolio that needs to be part of the overall solution. Say then, in terms of just how do we work together and what does that mean for all of us? It really means that as we take the opportunity, it's what Brian was saying a little bit earlier about relevance. There's got to be relevance in terms of when we talk about wind. Relevance means you've got to be able to do the three things we talked about. It's clean, we know it's clean, but it's got to be safe and reliable, and we've got to make it cost effective. The more we can do that, the more we can use wind. And I think that's where the excitement comes with all the R&D efforts and all the investment we're making is I think every year we get better and better at it. But for a big utility like ourselves and a big generating company, we're looking for that opportunity to use wind, but it's got to be in a way that our customers are going to pay for it. And so I think we want it to be safe, we want it to be reliable, it's got to be cost effective, and it's clean. And wind has the potential to do all of that. And so I think for us, what we're excited about, and our chairman, John Rose, actually the chairman of the board here at IIT, is a real commitment to continue to work on the research side, whether that's the smart grid or whether that's on the side of the wind. But we have to continue to find those opportunities to meet the challenge, but you have to do it in a way, again, that's safe and reliable, that's cost effective, and that's clean. So, that would be our position, that would be kind of our viewpoint of where we're going. It's an inevitable end state that we're going to be at a cleaner energy future. The question is just how long will it take to get there? I think the sooner we can develop better technologies, whether that's smart grid, better wind, the faster we'll get there, and I think that's better for everybody. So appreciate the opportunity to speak to you, and I look forward to the questions.
We can probably entertain a question if somebody have a question right now.
I think in terms of new nuclear, we're not going to see a lot for the reasons that you articulated. I think the cost, for a number of reasons. One is the risks are very high when it comes to a cost perspective. So if you see new nuclear, it's going to be in regulated markets, where basically, just like they were built in the old, the original nuclear plants were built in a regulated world, the folks who are kind of at risk if there's cost overruns are the customers. If you're talking about in a deregulated or pure independent power producer like Exelon is, we're not going to build new nuclear. The risk is just way too high from a cost perspective. I think we believe that it's a vital, important part of the solution, but given where the economics of it are today, I don't think you're going to see a lot, except in a fully regulated place like Southern and the Southeast. Does that answer your question?
Thank you, Sunny. Next is Michael Polsky, is the President and CEO of Wind Energy.
I'd like to comment about nuclear. If Exelon, which is the largest nuclear utility in the country, says that nuclear doesn't make sense, it means a lot,
Well, I'm going to be clear. I didn't say it didn't make sense.
No, I'm sorry, new nuclear.
If there's any reporters out there, let's just be careful.
Also, our speeches got progressively shorter, so I'm not going to be long. But, all right, I don't, for those that are interested in energy, so I'm not going to talk a lot about Energy, although Energy is involved in thermal generation, in wind, and now we're getting in solar. We're probably 5th or 6th largest wind generator in the United States with 2,000 megawatts running plus more in construction. But, this panel is about future wind, and Sunny said very few interesting things. He believes that wind has a lot of nice attributes, and it's important for the future. And the reason I was always in thermal generation, and when I started a new company in 2002, I sort of looked, what's the next big thing, just purely from a business perspective. That was 2002, 2003, and I look and I start seeing, obviously, people start thinking about cleaner environment, okay? So in other words, coal seems to be not a good fuel, and renewable wind in particular is clean. People start looking at national security, particularly after 9/11, something that we produce domestically, so wind makes a lot of sense. People start looking at fuel diversity, obviously, portfolio effect, as you mentioned. You don't want to have 100% depends or largely depend on one source. In 1950s, we thought nuclear would be too cheap to meter. You can see that this now is the most expensive thing. I'm talking new nuclear. So that's not a good thing to rely on one fuel. The whole volatility of energy prices, people start worrying about that. And economic development. So I look at that and I thought, it seems like wind in particular, and from renewable standpoint, it was lower cost renewable, very economical renewable. I thought it would make sense. Now we're sitting in 2010, same criteria applies. In 7 years, a lot of things in life, when you look 7 years ago and today, justification is totally different, or whatever made sense before, mostly in life doesn't make sense today. But if you look at wind, it did make sense before, and it makes even more sense now. If you look from a new generation standpoint, and I'm just speaking for myself, obviously other people may argue, is the lowest cost new generation by far less than nuclear, by far less coal than coal, probably comparable to gas today, natural gas, where prices are all-time low. So obviously some people say, yeah, but wind is intermittent. So my point is, if you have 20 or 30% wind on the grid, intermittency doesn't make any difference because you can absorb one may argue that because wind is distributed, it's very dispersed. You have a lot of generation. Somebody mentioned, Brian, we have 30,000 units around the country. If you build one large coal or nuclear unit, you have to have system backup and unit fails. If there is all problems with this. With wind, yeah, wind may die down, but we have some prediction technology, but we don't have any single unit failure problem. So one may argue that grid become more reliable with wind than less reliable. And as far as, like I said, as far as intermittency, we have a lot of other generation resources on the system that can absorb intermittency of the resource. And there are a lot of work being done. So, as I said again, 2003, 2010, and I guarantee in 2020 we'll probably be making same arguments, to justify as we did before. It'll make a lot of sense. So the question is, why do we make these arguments? 7 years ago, and I'm sitting here in 2000, still arguing about this, because the problem is we have no policy. We have no national energy policy that allow people, entrepreneurs or other company to really change the future. We still, unfortunately, our system is antiquated. Who sets our national policy? Those that own and control energy resources today. Obviously, electric utilities, coal companies, whatever. So in energy, you don't produce anything new. I was telling people, if you have a new iPhone, we put on the market, people buy, because it's a new product everybody wants. When we're in the electricity business, whether we build a wind farm or coal or nuclear plant, we still produce same kilowatt hours. So consumers see no difference whatsoever. Even if you produce, and when I got in the wind business in 2003, what struck me was, even I was at that time in energy, in electricity, I thought, oh, we're going to generate cheaper, because at that time, wind was even less expensive because turbine prices were lower and the whole structure was less expensive in some ways. So you could produce wind for 3 cents a kilowatt hour. You go to places where it's regulated, or even it's unregulated, and you can sell because nobody gives you the contract. So how can you build a wind farm spending hundreds of millions of dollars if nobody wants to buy electricity, even if it's cheaper than the electricity produced from the existing resource? So that system really does not work. It didn't work before, and in many places it still doesn't work. You probably hear around saying that contracts are scarce, people don't have contracts. That's the problem. It doesn't matter what the cost is, you just can't get a contract. Even if you're less expensive than existing coal plant or other resource. So that's why in energy, unlike in high tech, consumer goods or any other business where there is a free market, where you can produce product better, cheaper, nicer, whatever, market certainly absorbs it and takes it. In energy, we don't produce anything new. Plus, we produce an existing sort of regulated or semi-regulated environment, and you need long-term commitments, which market doesn't give you. Market is just short-term. You cannot, go to the market and say, because market today is this, 20 years from now is going to be the same thing. So that's the problem. That's a problem of deployment of renewable resources, because system really is not conducive to this. So what do you need? You need national, or now we have some states, we need energy policy. And what energy policy is, it doesn't skew the market. It basically tells what as a nation we want to go in the future, which way. Because, like I said, we already have infrastructure. That's why you need planning. Just like same as building infrastructure, whether you build road or water systems or whatever, we just want to, if we want to live cleaner, if we want to live in a new way, if we want to live even with lower prices than today, you got to change the rules, okay? Just like AT&T was broken. I mean, market did not break it. Somebody came and said, we want to regulate it to break it. Same in energy. We need policy and we need long-term policy. Otherwise, in 2015, we will be still talking same thing. Why we don't have enough wind. You know, another thing what wind did in the system, I don't know what the time is, but I still have a few minutes. What wind, people say wind is more expensive in some cases. Now lately it's less, but you know, it's periodically, generally people that against say, oh, it's more expensive. It's not more expensive, but what's expensive means, yeah, you may produce more from this particular wind farm, but wind has very important, unique attribute. It has practically zero feed-in cost, meaning that variable cost of wind is zero. What that means? It means it displaces all other resources on the system, either nuclear, even nuclear, okay? So what it means is depressed market prices in most jurisdictions. There was electrical power daily. Some of you may read, there was some studies saying, oh, wind prevents construction of new baseload plants and reduce price of electricity. It does. So you may have 6 cents a kilowatt hour fixed cost wind farm you build, but because it has zero feed-in costs, it depresses markets. So one may argue, and I'm in particular, that nation significantly benefit from a wind farm. So when you hear people say, oh, wind costs more, that's just to argue why not to build it because something else already exists, and I don't want to sort of let market forces to, you know, to allow for new generation. But I think you know that you look at Texas, you look at now PJM and Illinois, prices have depressed significantly because of wind generation. And that's what would happen in other parts of the country because wind as a unique variable resource with very low cost, which first really in the dispatch stack, it depresses prices of everything else. I'm not saying it's good for everybody because everybody needs to make a fair return, but there is this element of this. So we sit in here with the renewables that make sense, reduces the cost, again, benefits from environmental security, jobs, whatever standpoint, and we still argue. So what I want to conclude again, we need national energy policy. We need a policy that really lets that leap, okay, from now to where we need to be. Otherwise, unfortunately, you know, even if you, especially electrical utility industry, because it's highly regulated, or markets are very short-term, and when you build new, you need long-term commitments, okay? It doesn't work. It's not iPhone, it's not high-tech, and when people said we have open markets, we are a free country, United States, we all operate by market. It's not an electrical industry. Maybe someplace else, but not in the electricity industry. So that's why we need policy that will benefit my generation and your generation and generation after you and after you and after you. It's investment in our American infrastructure. Renewable, unlike any other power generation source, when you build a gas plant, it's 20-year life, 20Y, you maintain, you don't know. You build coal plant, same thing. You know, when you have nuclear plant, it has end of life. With renewable, you don't have end of life. When you build a wind farm, you may have a bit of wind turbine there or replace components, but it would run forever. That's what called infrastructure. That's why wind is not just a generation facility. It's not just a power plant. It's a national infrastructure. So, again, thank you very much, and I appreciate it.
We can entertain one question, if you want.
I have a question to follow up on what Michael just said, and I'd like to address it also to Sunny. Michael, as I understand, not the part about Victor, I'll leave you alone. But Michael, as I understand what you're saying, that wind, because if you build enough wind farms, you solve the baseload problem by having overlay. And as we know, 25% of U.S. coal plants
So next 300,000 megawatts, if we really have good national RPS and we have 20% additional renewables, we can avoid any base load for the next 20 years. That's what I'm saying here. We don't have to worry about base load. I'm not saying is that we have to rely 100% on wind. As Sonny said, it's portfolio. So in a 100% portfolio, if we have 20% nuclear by energy now, why would we not have 20% wind by energy? Then maybe we'll still have 30% coal left. Nobody argued, including me, for shut down the entire coal fleet in the United States. It's not going to happen in several lifetimes here. But from the portfolio standpoint, I really personally, don't see any need for any base load for a generation, or maybe more, because we can take care of this with traded wind. That's what I'm saying.
Can I just follow up? I'm sorry. Okay. I mean, I think the other piece of your question to keep in mind is when do you need that base load, right? And so it's peak or off peak. And so I think you got to think about that as well in terms of where wind will fit in.
Thank you. We continue this discussion during the panel. The next is Paul McCoy. He is president of Transelec. Paul.
Thank you. Well, first of all, I'd like to thank Dr. Shahidapur and the university for the invitation to speak to you again. It's a great honor for me as a graduate of this university to be here. It's quite a thrill. So we're gonna move a bit from, let's just say general policy into something that the engineers just love. We're going to get into some technology issues. And I'm going to talk about, as you see the title, smart transmission, make it smarter. I'm referring to high voltage transmission. So think of 138 kV and up in this neck of the woods and in the Eastern Interconnection. And I'm going to posit, as I was talking to Michael Polsky before the presentation here, we were talking about integration and penetration of wind, and the levels that he's talking about, 20%, the DOE approach of 20% by 2020. If there's a national res of 15%, those are completely achievable in almost all parts of the country. But we've got to get on with the technology side of this, and I'm going to talk about that and leave you with some thoughts. So in my view, smart transmission is the intersection of four elements. First of all, there's the physical infrastructure of the system. As Sonny said, we can't, all the technology in the world and the gee whiz bang stuff that is on the horizon or even now is not a substitute for the fundamental infrastructure of the grid, and we'll get into that. Clearly, advanced information technologies are key. Measurement, analytics, automation, and controls, we'll talk a bit more about that. Most of the mainline utilities are rolling out high-speed, bidirectional communication. We'll talk a bit more about that to deal with control commands and the hierarchical communication of data and what all that means and what you use it for. And then the thing a lot of people focus on because it's neat, you can put your hands on it and feel it, and that's advanced components, superconductors, energy storage, which I think is absolutely key in all its forms. I'll get into that later. Power electronics, utility scale, flexible AC transmission, and the increased and more aggressive use of high voltage direct current in a variety of applications. The impacts on renewable generation. As I said, continued investment in the towers, I should say, wire substations, is still needed essential for fundamental renewable generation access. It's not an accident that Illinois is moving into the lead nationwide in the installation of wind turbines, not because it's got the best wind, but on an all-in basis, all costs included. You balance the slightly less good wind compared to, say, the high plains, 700 miles to the west. But guess what you have here? You're right next to the markets, and you have transmission access. So if you're Invenergy, the all-in cost to connect here, when you run the numbers, is cheaper than building 700 miles away and then having to build several $1 billion of transmission. Clearly, deployment of advanced technology is critical to integrate the new forms of generation of the grid reliably and lower cost. It's only about 4 years ago or 5 years ago that individual utilities across the country were waving their arms, screaming, the sky is falling, we can't integrate more than 5% wind, we're going to do a test, we're going to caps because they were looking at the universe through blinders. When you step back and do wide area integration, guess what? The costs go down. And so you've seen a dying away of individual utilities screaming and yelling, and it's going to cost us $10 a megawatt hour, a penny a kilowatt hour to integrate wind. It just isn't the case. And we need to do this fast. Full disclosure, I spent 27 years with the hometown utility here, and I am just an absolute critic of the utility practice of every utility doing their own alpha and beta testing with established commercial technology. All right, this isn't research. No other industry does this. So you can have a utility right next to you having deployed dozens of, pick your technology, advanced relaying, a new breaker design, whatever it is, new control room software, man-machine interface. Guess what? The next guy over wants to do a test for 3 years. You don't do that in the airlines. You don't do it in any other industry. You know, the industry, the suppliers validate their equipment, and that's where we need to get to. What does the law say? The Energy Independence Security Act of '07, I'll let you read this. Basically, it mandates the increased use of high technology, dynamic optimization of the grid, and again, dealing with cybersecurity for nation-state warfare. And this is mainly a distribution issue, but again, the proprietary vendor protocols need to be eliminated so things can be plugged into each other and made to work together so costs go down. Let's now dissect this a bit. On the technology side, there's this family of things: communication, sensing technology, and measurement. Lots of owners, as I said, have been investing in high bandwidth communication networks, fiber, some network microwave, which is high bandwidth, to collect network information and then deal with the C3 structure, command, control, and communication between the remote devices and the control center. Advanced sensing. There's a technology that's been in development for several years now. It's an outgrowth of the 2003 blackout in the Northeast, which I was kind of in the middle of. And that is a technology that, with sensors, allows the control room operators and the providers, regional providers like the Midwest ISO or PJM, to visualize the network on a contour map and the phase angle relationships of the entire network related to a reference bus. Because as the network gets stressed, what happens is, for the electrical engineers in the room, power engineers, the phase angles move apart. You can't see it. You haven't been able to see it. But as the network gets stressed and these phase angles move apart, it's a clear indication, no matter what else you're seeing, that trouble's brewing here. If that technology in August of 2003, it is likely that people like AEP, the Midwest ISO, and PJM could have moved to sort of grab First Energy by the throat and say, you've got a problem, a serious problem that's emerging here right in northern Ohio. But what it requires, as you see, is much higher sampling rates. SCADA samples at 2 to 4 second intervals. You must sample it multiple times per second to get proper phase angle information. Well, that's the good news. The bad news, or the downside of it, is this new technology produces mountains of raw data. Mountains. And it can overwhelm system operators or any other operator. Therefore, the industry is deploying, and suppliers are moving aggressively to deal with the data. Modern substations now typically have, brand new substations today would have a redundant LAN network, multiple on-site computers, which except they're in a rack. Much data collected is just normal stuff. Amps, watts, bars, phase angles, whatever it is, temperatures on the transformer, pressures in SF6 breakers, battery voltages. That stuff is just stored. It's uploaded at night when the network may have capacity or any other time the network has capacity. Critical information, change of status, alarms, abnormal situations, security breaches, anything like that is sent immediately. It's processed in the control room, and this is critical, to present the operator with the most critical information. And this is learning this industry, the transmission industry, has learned in large part from nuclear. You know, an upset, a normal, for those of you who have ever been in a control room at a 2-unit nuclear plant that's running at full power, It's the most boring place on the planet. There's absolutely not an alarm on the board. Everything's quiet. It isn't. So suddenly there's an upset. It could be an external upset on the power system. Loss of off-site power is the most extreme event, unit full load. All hell breaks loose. Hundreds and hundreds of alarms. Human beings have been known, you can't deal with more than 3 or 4 events at one time. So modern technology suppresses things like the service water pump failed. Who cares? The most important stuff is presented to the operator with a man-machine interface visual display that he or she can deal with now and process. Then the next most critical data comes up as they mitigate the most severe event. That's what needs to happen and is happening today. Ultimately, the data is stored. You get, for post-operation review, back testing. In other words, one of the things is, with data you have, real data, what if we replayed the power system yesterday? And whether you're trying to optimize losses or you're looking at unit commitment, what if we did things differently? Now, again, keeping on this theme, it's no good if we can't manage in real time. So what's going on today? And some of this is old hat. I would say that any Class 1 utility that isn't using these tools is deficient. State estimation has been going on for 20 years. Topology processors is something a little new, and that's just to take a look at the existing connection of the system, whether there's elements missing from maintenance or they've been forced out. What does that mean and how does it feed into state estimation? Security-constrained economic dispatch and security-constrained unit commitment are standard tools. Most operators are very experienced with this, especially your senior operators who deal with whether it's a non-market or market environment on unit commitment and dispatch for the next day and in real time. And then post-contingency analysis. Something happened. What happened? Why did it happen? What do I do? But what's going to happen next? The whole suite of advanced operator tools, some of which are being rolled out, some of which will be rolled out. And I think the industry needs to think, as I say here, think Boeing 777. It's an amazing machine. It diagnoses its own problems and suggests the fix to the pilots. Its computers determine the power settings on the engines for takeoff based on the length of the runway, the temperature, the altitude, and the weight, again, the weight of the airplane, the amount of fuel on board. The pilots can override, but there's no reason to do so. There's tiered information processing. We talked that, including drill down. So basically, if an operator sees something and then they're doing an analysis, you now can open up the data and drill down to look at the source data if you want to do that, but you don't have to. Again, we talk about the nuclear approach. In severe events, you suppress data that isn't essential to saving the system or solving the problem. It rolls up, or it can be made to clear the severe event. Other things, congestion management visualization, kind of a corollary to the synchrophaser displays. Where's congestion in my grid? Right now, this is done offline, but more and more it's being done in the control room real time with color displays, contour maps. Where are my heaviest loads? Where am I approaching operational flow limits? Those sorts of things. Wind forecasting tools. The Texas event was a wake-up call. The interestingly, that loss of wind occurred toward midnight. And so the industrial customers in ERCOT in Texas, the Texas grid operator, got calls in the early morning hours to exercise their interruptible riders in the middle of the night because frequency was dropping. The reverse occurred in the upper Midwest several months later, where as loads were coming down at night and west to east transfer schedule market, guess what happened? All of a sudden, a whole bunch of wind appears in Minnesota. Many, many hundreds of megawatts, which then causes a high voltage overload, and effectively, as generation in the dispatch gets forced down, what they call a minimum generation emergency. Both events are not good. So rapidly, the industry responded with wind forecasting tools, both on a large scale and what they call a mesoscale basis, smaller scale, where you get warnings of impending wind shear events, fronts. So you can deal with these now, and by the way, Michael, I don't call wind intermittent, I call it variable, where you deal with these ramping events on wind, more and more forecasted, fit into the dispatch and accounted for. We talked about the synchrophaser displays, and kind of one of the holy grails of the truly advanced support tools is automatic and remote resetting